بسم الله الرحمن الرحيم. موضوع محاضرتنا اليوم هو Discrete Fourier Transform DFT. So the Discrete Fourier Transform, the DFT اختصارا بنسميه DFT. طبعا الديسكريت فورير ترانسفورم هو جزء من عنوان كبير اللي بنسميه احنا finite discrete time transforms, finite length discrete time transforms. So it is part of finite length discrete time transforms. Okay. So discrete أو finite length discrete time transform مفروض يكون دائما في finite length n and second condition always x of n starts from n equals 0 up to n equals equals n minus 1. Okay, n equals n minus 1. Okay, so x of n for n between 0 and n minus 1. So this is generally speaking about the finite length discrete transforms. Under this we have something called orthogonal transforms. من أنواع الأورثوغونال ترانسفورمز اللي هو our item أو our title اللي هو DFT. في كمان اللي هو Discrete Cosine Transform. وفي كمان إشي اسمه R Transform. راح يكون إحنا شغلنا في هذا الكورس بيتعلق في DFT mainly. ما راح نتعرض للآخرين، لكن إذا أي حدا بيحب يستزيد منهم موجود هذا الحكي في الكتاب المقرر تبعنا. Okay, so let's begin with our title اللي هو DFT اللي هو Discrete Fourier Transform DFT. As a definition, we have the transformed domain x of k equals to summation from n equals 0 up to n minus 1 x of n e to the minus j 2 pi k n over capital N. This is for k between 0 and n minus 1. So this is the forward direction of the DFT. The x of n is our sequence in time domain, x of n. This is the time domain sequence. This is the form of the transformation. And x of k is the transformed sequence in the frequency domain. So x capital means that you are in the frequency domain. The index also k is in the frequency domain. The index n for the time domain, and the lowercase x is for the time domain also. Okay, now we will go to take the other part, which is the inverse DFT. Inverse discrete Fourier transform. x of n, so this is the time domain once again, equals to 1 over n, this is the normalizing factor, times the summation from k equals 0 up to n minus 1, x of k e to the j 2 pi, so we do not have a minus sign here, 2 pi k n over n. This is for n between 0 and n minus 1. Okay, so this is the first equation here. This one is the definition or the Fourier transform in the forward direction. And this one here is the inverse discrete Fourier transform in the reverse direction. Normally we can say that, put it in a symbolic representation, that we have x of n with an arrow for both sides, DFT of x of k. Let's take an example, very simple example, and see how can we evaluate the DFT using the definition. So our example here, find the DFT of the following sequence. X of n equals to 1, 2, 3, and 1. So we have a 4-point sequence starting from x of n equals 0, it's equal to 1, 2, x of 1, x of 2 is 3, and x of 3 is 1. Okay, and we are using the definition. Okay, so this is our example. So let's start by putting the definition of x of k in the forward direction. So this is the summation from n equals 0 up to 3. So we have from 0 up to n minus 1, n is equal to 4. So this is 3. X of n e to the minus j 2 pi k n over 4, because n is equal to 4, and this is for k between 0 and 3. Okay, so this is how to implement the definition when we have n equals 4 points. Now, we start by x of 0, so we have k equals 0, so we substitute this in the summation from n equals 0 to 3, x of n e to the minus j 2 pi times 0 times n over 4, and this is equals to the summation of x of n itself from n equals 0 to 3. This is equals to 1 plus 2 plus 3 plus 1, and this is equals to 7. So the x of 0 in the frequency domain is equal to 7. Now x of 1 is equal to the summation from n equals 0 to 3, x of n e to the minus j 2 pi 1, substituting for k equals 1 times n over 4, and this is equals to 1 times e to the j minus j 0 plus 2 e to the minus j pi over 2 plus 3 e to the minus j pi plus 1 times e to the minus j 3 pi over 2. So this is equals to 1 minus j2 minus 3 plus j, and this is equals to minus 2 minus j. So x of 1 is equal to minus 2 minus j. X of 2, with the same procedure, we can find it as summation from n equals 0 to 3 x of n e to the minus j 2 pi times 2 times n over 4, and this is equals to 1 times e to the minus j 0 plus 2 e to the minus j pi plus 3 e to the minus j 2 pi plus 1 times e to the minus j 3 pi. And this is equals to 1 minus 2 plus 3 minus 1, and this is equals to 1. The last one, the last item in the sequence in the frequency domain is x of 3, and this is equals to the summation from n equals 0 to 3 x of n e to the minus j 2 pi times 3 times n over 4, and this is equals to 1 e to the minus j 0 plus 2 e to the minus j 3 pi over 2 plus 3 e to the minus j 3 pi, and the last one is 1 times e to the minus j 9 pi over 2, and this is equals to 1 plus j2 minus 3 minus j, and this is equals to minus 2 plus j. So the end result of x of k will be x of k is equals to 7 minus 2 minus j, 1 and minus 2 plus j. So this is our sequence in the frequency domain, and this is our answer here. Okay? All right. So let's take this example and try to find the inverse, go to the inverse direction. So we'll take example number 2 and do the inverse. We need to find the inverse DFT of the sequence x of k equals to 7 minus 2 minus j, 1 and minus 2 plus j. And see that we have to, at the end, we have to find that it is the original x of n that we have in the first example. So x of n, in the definition of the inverse Fourier transform, it's 1/4 the summation from k equals 0 up to 3 x of k, and now we have e to the j without the minus sign 2 pi k times n over 4. And this is for n between 0 and 3. So now n is the variable here. K is the index for the summation, and we will start evaluating the time domain x of n by starting with x of 0. X of 0 is equal to 1/4 the summation of x of k e to the times e to the j 2 pi times k times 0 over 4. And this is equals to 1/4 of the summation from k equals 0 up to, these are the same, k equals 0 to 3 x of k. So this is equals to 1/4 times 7 minus 2 minus j plus 1 minus 2 plus j. Okay, So this is equals to 1/4 of minus j with minus j. We have here 7 plus 1, 8, minus 4, so we have 4. And the end result is 1. So x of 0 is equal to 1. Okay, let's implement also x of 1, and I will leave the rest of this as an exercise for you. Okay, so we'll have x of 1 equals to 1/4 the summation from k equals 0 up to 3 x of k e to the j 2 pi k times 1 over 4. So we substituted n equals 1 in this summation. So this is equals 1/4 times 7 times e to the j 0 plus minus 2 minus j e to the j pi over 2 plus 1 times e to the j pi plus minus 2 plus j e to the j 3 pi over 2. So this is equals to 1/4 of 7 minus j2 plus 1 minus 1 plus j2 plus 1, and this is equals 1/4 times 8. This is equals to. So I will leave this as an exercise. So you will find x of 2 and x of 3 as an exercise. Okay, so we find an example, or we did an example using the definition of the Fourier transform. Using the definition of the Fourier transform. Now we will try to find some easier method to find the DFT. We will define the matrix form of the DFT. Matrix form of the DFT. So we'll stop here and we'll do it in another session. Thank you.